Hello, everybody. So today we're going to finish chapter 10 in our fifth grade Go Math textbook. Our concept today is elapsed time. And basically, how can you solve elapsed time problems by converting units of time? And we're on page 453 of your textbook. So let's look at the unlock the problem. A computer company claims its laptop has a battery that lasts 4 hours. The laptop actually ran for 200 minutes before the battery ran out. Did the battery last 4 hours? Well, we know that in 1 hour there are 60 minutes. And remember that when the minute hand moves from one number to the next, that's a period of 5 minutes, right? So 5 times 12 is 60. All right, so what do we need to do? We need to change the 200 minutes into hours and minutes. So how many total minutes? There was 200. We need to divide by the number of minutes in an hour, which is 60. All right, well, 200 divided by 60. How many 60s can I take from 200? 3. 3 60s is 180. And that would give me a remainder of 20. So it's going to be 3 hours, 20 minutes. So 200 minutes is 3 hours and 20 minutes. So now let's compare that. 3 hours, 20 minutes is less than 4 hours, right? And so since 3 hours, 20 minutes is less than 4 hours, the battery did not last as long as the computer company claims. All right, let's try this problem. Jill spent much of her summer away from home. She spent 10 days with her grandparents, 9 days with her cousins, and 22 days at camp. How many weeks and days was she away from home? Well, so what do we need to find? We need to find the number of days away, right? But then our question says how many weeks and days. So we're going to convert the number of days into weeks. We know that there's 7 days in a week. And anything less than a week will be left over, right? So we know that she spent 10 days with her grandparents, 9 days with her cousins, and 22 days at camp. So let's just add those up. 22 and 10 is 32. 32 and 9 is 41. So 41 days. So we're going to convert that into weeks by dividing by 7. And I know 7 times 5 is 35. And that'll give me a remainder of 6. And the 6 represents days. So 5 weeks, 6 days. So she was away from home 5 weeks and 6 days. Okay, you might want to spend some time reviewing, making sure that you know these conversions. Know that 60 seconds is a minute. Know that 60 minutes is an hour. 24 hours is a day. 7 days is a week. There are 52 weeks in a year. There's 12 months in a year. And there are 365 days in 1 year. And that does change for leap year every 4 years. So an extra day. All right, page 454. So we can also use a number line to find elapsed time. Elapsed time means the amount of time that has passed from the start of one activity to the end. So she spent 2.5 hours working on her computer. So that's the elapsed time. It spent 2.5 hours. She started working at 10:30. What time did she stop working? So we can use a number line, and we can go 10:30 plus an hour because we know 2.5 hours. So 10:30 to 11:30, that would be 1 hour. 11:30 to 12:30 would be another hour. So that's 2 hours. And then we're going to go 12:30 to 1. And that's going to be the half hour. Okay, so half an hour is 30 minutes. 30 minutes plus 12:30 would be 1 o'clock. So she finishes working at 1 o'clock. Another way, we could just use a clock. So we see that right now the start time is 10:30. Well, if an hour goes by, the hour hand is going to be in the same location, exactly in between 10, like it is between 10 and 11, but in between the 12 and 11. So that shows that it would be on this side right here at the end of 1 hour. At the end of 2 hours, it would be in between the 12 and the 1, the hour hand. And then we'd have to add 30 more minutes, and it would be ending at 1. So that's why you see three different colors here. Okay. The larger triangles represent 1 hour each, and then the next one is a half an hour. So she stopped working at 1 p.m. All right, so we can also find a start time if we know how long, when the activity ended and how long that activity lasted. So Robert's soccer team needs to be off the soccer field by 12:15 p.m. Each game is at most an hour and 1 3/4 hours long. What time should the game begin to be sure that the team finishes on time? So we need to be off the field at 12:15. We can only have the game last 1 3/4 hours. So remember that 1/4 hour is 15 minutes, right? We could take a clock and break it into 4 equal sections. And each fourth is 15 minutes. 5, 10, 15, 5, 10, 15, 5, 10, 15, so on. Okay. So if we have 3/4, that means we have 3 sets of 15 or 45 minutes. So the games at the most can last an hour and 45 minutes. Well, we can work backwards then. If the game started at 12:15, we can back up 45 minutes. So from 3 to the 12, that's 15 minutes. And then from the hour to the 9, that would be 15 more minutes. So that's 30. And then from the quarter hour to the 6 would be 45 minutes. So we know that if we subtract 45 minutes, we would be at 11:30 a.m. All right. So again, we need to end at 12:15. So if we're at 12:15, we take away 45 minutes, we'd be at 11:30. If we take away an hour then from 11:30, we know that we're just going from halfway in between 11 and 12 to halfway between 10 and 11. That would be 1 full hour. So the game has to start no later than 10:30 a.m. All right. Let's look at number 1 on page 455. We need to change 540 minutes into a number of hours. Okay. So we know we can take 540 and divide by 60 because there's 60 minutes in an hour. Since the dividend ends in a 0 and the divisor ends in a 0, we can divide by 10, and 54 divided by 6 is 9. So there are 9 hours in 540 minutes. 8 days is how many hours? Well, we know 1 day is 24 hours. So we're going from larger to smaller. So 8 times 24 would be 192 hours. 110 hours is how many days and hours? So we're going from smaller to larger. So we're going to take 110 and we're going to divide by 24. Well, 5 times 20 is 100, and 5 times 4 is 20, so that would be 120. So 5 is too many, so let's try 4. 4 times 4 is 16 ones. Regroup as 110 and 6 ones. 4 times 2 is 8, plus 1 more is 96. Okay, so let's subtract that. The remainder in this problem is going to be the number of days. Sorry. Okay, so 10 take away 9 is 14. So we have 14 days left over. So we have 14 hours, 4 days and 14 hours. So the remainder in this problem is the number of hours. Okay, the quotient is the number of days. Okay, so 4 times 24 hours is 96 hours. 10 take away 96 is 14. So we have a remainder of 14 hours. All right, find the end time. If we started at 9:17 a.m. and our elapsed time was 5 hours and 18 minutes, well, I'm going to go 9:17 plus 18 minutes first. And 8 and 7 is 15, and 3 tens is 35. So we know that it's going to be 35 minutes. And now we're going to add 5 hours to the 9. So we can just go 9, 10. That's 1, 2, 3, 4, 5. So it's going to be 2:35 p.m. Number 5, find the start, elapsed, or end time. Well, they gave me the start time here. The elapsed time was 3 hours and 10 minutes. So what's the end time? Well, let's again start by adding the minutes. And 11:38 plus 10 minutes would be 48. So it's going to be something 48. Now we're going to add 3 hours to the 11. So 12, 1, 2. 2:48 p.m. Okay, all we counted was we went forward 3 hours from 11. 11 to 12, 12 to 1, 1 to 2. Number 6, we need to find the start time this time. They give us an end time of at 1:15, and the activity lasted 2 hours and 37 minutes. Well, so if we're at 1:15 for the end time, and I have to subtract 37 minutes to find out where it started. Well, I know I can't take 37 from 15, so why don't I just back up by 15 first? Okay, so now that would put me at the hour mark, right? And 37 minus 15 would give me 22 more minutes. So what's 60 minus 22? 38. So we know the number of minutes will be 38. And now we need to back up from 1 hour. So if we take away 15 minutes, we'd be at 12, right? We're taking away those 15 minutes. I'm sorry, 1 o'clock. 1 o'clock. And if we take away 38 more minutes, we'd be at 12:22. If we take away 22 more minutes, we'd be at 12:38. Okay, let me back up. Okay, so what did I do? I started with the 1:15 end time. I took away 15 of the 37 minutes, and that put me at 1 o'clock. I then took away 22 more minutes, just because that 22 plus 15 is 37. And if I take away 22 minutes from the hour, that puts me at 38. And I go back the hour, so I'm at 12:38 right now. By taking away the 37 minutes. Now I need to take away 2 more hours. So 10, 11, 10. It will be 10:38. 10:38 a.m. Number 7. Our elapsed time is 2 1/4 hour, or 2 hours 15 minutes. Our end time is 5:30. So 5:30 take away 15 will give me 15. And 5 take away 2 is 3. So this activity started at 3:15. And number 8. The start time was 7:41 and it ended at 8:50. So we can just subtract those, okay? I can't take 1 from 0, so let's regroup. So we have 9 minutes, and 8 take away 7 is 1. So the activity lasted 1 hour, 9 minutes. Number 9, how could you find the number of seconds in a full 24-hour day? Okay. Multiply 24 hours by 60 minutes per hour times 60 seconds per hour. 60 seconds per minute. Okay. So 24 times 60 times 60. Well, 60 times 60 is going to be 3,600 times 24. All right. And 4, 6, 7, and 1 is 8. So 86,400 seconds. 86,400 seconds per day. Okay. All right, let's look at number 10 on page 456. Which internet services downloaded the podcast in less than 4 minutes? Well, 4 minutes times 60, right? There's 60 seconds in a minute. So which companies did it in 240 seconds or less? Okay, that was not, because it says time in seconds. So that's not less than 4 minutes. 173 is. So Groovebox did it in less than 4 minutes. Did anybody else? No. Yes. Internet C. And Red Fox was close, but it was over the 4 minutes. Okay, so just those two. Which service took the longest? Well, which one's the longest bar? Top Hat. How much longer did it take than Red Fox? In minutes and seconds. All right, well, let's take the number of seconds first and subtract those two. Red Fox was 310. So they did it in 740 seconds. So 740 divided by 60. Okay, we can't take 14 from 60, so we'll change that to 141s, bring down the ones that we already have, which is 0 in this case. So 141s divided by 60 would be 2. So we'd have a remainder of 20 seconds. So it's going to take 12 minutes and 20 seconds longer. Number 12. If both Jackrabbit and Red Fox started the podcast download at 10:05 a.m., at what time did each service complete its download? What was the difference between these times? All right, so Jackrabbit, we'll call that JR, started at 10:05, and they finished in 980 seconds. 980 divided by 60. So they finished in 16 minutes and 20 seconds. So at 16, that would be 10:21:20. 10:21:20. And Red Fox, 310 seconds would be 5 minutes and 10 seconds. So 10:05 plus 5 would be 10:10 and 10 seconds. So 10, 10, 10. What's the difference between those times? Well, it's going to be 11 minutes, 10 seconds difference. Okay, all we're doing is subtracting. 20 take away 10 is 10. 21 take away 10 is 11. So 11 minutes, 10 seconds. And finally, 13. Salmon and his friends went to a movie at 7:30 p.m. The movie ended at 9:55 p.m. How long was the movie? Okay, well, it ended at 9:55 and started at 7:30. We can just subtract that. So it was a 2-hour and 25-minute movie. Salmon arrived 35 minutes after the movie ended. What time did Salmon get home? Explain how you found your answer. So 9:55 plus 35. Well, I'm going to add 5 minutes, and that's going to get us to 10 o'clock. We still have 30 more minutes, right? Because all I've subtracted right now is 5 minutes. I'm sorry, all I've added is 5 minutes of the 35 minutes it took him to get home. So 10 plus 30, he would get home at 10:30 p.m. I added 5 minutes to 9:55 to get to 10. And then added 30 minutes to 10 to get 10:30. So again, I had 5 minutes of the 35 minutes, and that put me at 10 o'clock. I then had 30 more minutes to add, so 10 plus 30 put me at 10:30 p.m. All right, so that's it for our discussion of Chapter 10. In our final chapter of the 5th grade Go Math textbook, we were going to be talking about geometry and volume. So until then, I will see you soon.